السلام عليكم ورحمة الله وبركاته. Dr. Ahmed, can you hear me?
السلام عليكم دكتورة. دكتور محمود
أهلا.
موجود بس حطيه بالبانل لو سمحتي.
Dr. Mahmoud is here. Okay, I can't see him. لحظة واحدة. إيه تمام. Okay, دقائق بس. تمام. Dr. Mahmoud is a panelist. Okay, Dr. Mahmoud.
Yes, I'm here. I'm all good.
Yes, مرحبا دكتور. Hi, Dr. Mahmoud. How are you?
Alhamdulillah. I'm fine, thank you.
Okay, great. Okay, so we can start our workshop today. Dr. Mahmoud Al-Marzouqi is giving his third part of his workshop today, and it's titled Sensitivity Analysis and Robustness Checks. Dr. Mahmoud is an assistant professor in accounting at Aston University in the UK, correct? So we can start with you, the workshop, Doctor, and then inshallah, we'll have further details to announce later once you're done. The floor is yours.
Okay. Thank you very much, Dr. Hanan, and thank you, Dr. Ahmed, for the kind invitation. I would like to share my screen. I think I'm not able to share my screen.
Yes, I'll do that. One second.
Okay.
One second. Okay, can you share it now? Can you share the screen now or not yet?
دكتور محمود ظهر في خلل فني طلع. So please, دكتورة, can you give me the co-host please, دكتورة?
Sure. 1 second. Okay, you are a co-host, Dr. Ahmed. Dr. Mahmoud has left actually.
Yeah, he will join now.
Okay.
بس share, okay? Do you open it? Have you opened it?
I should, yeah, المفروض إنه he's able to share his screen now. Dr. Mahmoud, you're back?
Yes, I just been kicked out, and as an attendance, I came back as a panel here. So I check if I can share the screen now. 1 second.
Okay.
Yes, I can do share the screen. Yes.
Okay, great. Okay, please proceed.
Okay, thank you very much. So thank you very much, everyone, for joining us today and free your time to be with us in the workshop, part 3, when we discuss the sensitivity analysis in Stata and exploring the robustness check. Can you hear me? Correct? Can you hear me?
Yes, we can.
Okay, thank you very much. So we do some sensitivity analysis and we can start the robustness check phase. And in the next session, part number 4, we'll discuss in detail the robustness checks, GMM model to SLS model, and how to tackle heterogeneity. So the agenda for today is the part number 4 in the continent. So in the first week, in the first workshop, we discuss the data management and the descriptive statistics, how to clean the data, how to remove the duplicate, how to identify the data as a panel, and how to run descriptive and correlation metrics. And this is covered in phase number 1 or class number 1. If you want any question there, you can refer to the YouTube channel. And then in the last week, we discussed the regression model, and we discussed together the OLS model, fixed effect, and random effect model. Also, we touch a little bit of top-bit regression, probit regression, and mixed effect regression, and how to do Hostman test to identify which test is suitable for our data. So today we're going to focus on the sensitivity analysis phase, and the following time will be robustness check and additional analysis. So the sensitivity analysis is we need to make sure that our results are sensitive. So after running the sensitivity analysis, our results should indicate that the main findings are robust to any alternative measurement to our data. For example, to simplify this complicated term, if you're measuring the firm performance using the return on asset ROA, then if you change your proxy and you measure the firm performance using different profitability ratio, such as ROE, return on equity, the result should be the same. So what I'm trying to say here, if we measure the corporate governance using the board size, if we change the board size as an indicator and we use different indicator, for example, board independency, the result should remain in the same way as the main finding. This is the conclusion of the sensitivity analysis, to make sure our results are robust with the main finding. So we'll explore together the importance of sensitivity analysis and how to perform 3 or 4 types of sensitivity analysis. So we'll try 2 or 3 methods, maybe 4 methods. So we'll cover range method of assessing the sensitivity and robustness checks of our main finding. Also, you will learn how to use this data to conduct this analysis and what is the best practice to report the sensitivity analysis in your research paper or in your PhD, in your dissertation. Right, so by the end of this session, you will have a solid, better, good understanding of how to conduct sensitivity analysis, which is needed in your robustness check section in your analysis. So little bit rehearsal for the from our historical information we're given, that the data in your research methodology and data section and finding section, you should start by descriptive statistics, correlation, and then the main regression, OLS, fixed effect of it, or random effect, whatever you choose. And then you have a section called sensitivity analysis and section called additional analysis. So sensitivity analysis is our main core today. So we'll understand what is a sensitivity analysis. We can do some outlier test as well if we have time at the end. Robustness check, whether if we change the sample size, if we change a variable measurement, if you change a variable indicator, if you change any way of conducting your main regression, whether the result will be the same or not, right? This can be done through 4 main ideas or 4 main ways of sensitivity analysis, which highlighted in purple color. The first one, you need to make sure that our result vary under different specification of our model, and we're going to explain that, or our result will be in the same way if we use different control variable. Our result will be the same if we use different dependent variable or change the dependent variable to be binary variable. Binary mean dummy variable, 0 and 1. Or our result will remain even if you use some outlier detection technique, such as Cox distance or Mahalanobis distance. So to put that in practice, let's open a data, right? If we run a normal regression from last week regression, if we run normal regression, the impact of gender diversity in the profit, which variable should I put for? My dependent variable. So my dependent variable is profit measured by return on asset. Then my independent variable, the gender diversity, which we just said before. This is normal regression. We learned last week together. We examine the relationship between gender diversity and return on asset. How impact of the percentage of female in the board of director should improve or does not improve or does not have any relationship with the profitability. When we press enter here, the result will appear and we say this is the number of observation in the right hand side in the top corner. So we have 957 firm year observation has been included in this regression. We can see as well R square, adjusted R square. We can see as well the probability of the model, which is very significant here, should be less than 5%. We can see the p-value. If you remember from week number 2, the most important number we look here is the p-value. And the p-value is less than 5%. That means the relationship is significant. After we find it significant at 99% significant level, we look in our main variable, we find here that the gender diversity is positive. So the gender diversity improved the profitability. This is a main regression, right? So you run fixed effect, you run random effect, you run OLS, you run two-bit regression, you choose 2-3 model to run, and all of them has confirm or suggest, because the word confirm, it is not good to be used in the context of statistics. We should talk about likelihood. This is very important in our writing as well. Our result suggests, our result illustrate. We cannot say word like confirm because we don't have any definition. We all the time have standard error, as you can see here. There is always a chance of having error in our result. So we run this regression, which is all the information from last week, and now we want to do some sensitivity analysis to it. The first type of sensitivity or changing the proxies. What does it mean changing the proxies? In your research method section, when you write the research model, you will not write return on asset and gender diversity. You will write profitability and board diversity. Is that correct? Profitability is measured by return on asset. So the return on asset is not your main variable, it's a proxy for the variable. For example, readability. If you're doing a research about the readability and earning management, how are you going to measure the readability? Using FOG index on the right-hand side here. So when you run the regression, you will use FOG as a proxy for the readability, right? So this, what we use in the regression, it is not our main variable, it is a proxy or indicator for the main variable. So therefore, the first way of running sensitivity analysis is to change your proxies. So rather than using the return on asset as a proxy or indicator for the profitability, we rerun the regression, replacing the return on asset by another measurement of profitability. Let's say return on equity. Again, we are not in the context of explaining the methodology. That is another way. Like what can measure the profitability, you have to read the literature. Measuring the profitability can be done by ROA, can be done by ROE, can be done by return on capital employed, ROCE, can be done by revenue, can be done by gross profit margin, net profit margin, a lot of proxies. But if you use any other indicator, return on equity, instead of return on asset, and you press enter, if the result remains significant, which is not the case here, that means you can draw a conclusion that you have run a sensitivity analysis and you find out the relationship between gender diversity and the profitability is suggested to be significant positive. Why is not the case here? Because you can see the p-value is not under 0.05. So the relationship didn't hold itself. So this sensitivity analysis has failed, right? So if, obviously I'm using only as an example. In your context, we'll have different variables. As an example, because I'm using random sample, we cannot say here in our sensitivity analysis that gender diversity or board gender diversity improve the profitability. Why? Because when I run sensitivity analysis and I replace the indicator by another indicator, the relationship does not remain significant, right? Let's say if someone else replaces the return on asset by different measure of profitability, let's say total revenue. Enter. The relationship is still insignificant. So that's why the sensitivity analysis is important, because you might find initially the relationship significant, but it's a fake significant. When you run some sensitivity analysis, the result does not hold itself, right? So the rationale or the reason beyond running the sensitivity analysis is to confirm the relation, not to confirm, suggest, or stand along, aligned with the initial result, the gender diversity improve the profitability. So let's try another variable. Obviously, I'm just putting random variables. if I say that gender diversity will improve readability, so my dependent variable will be fog as a proxy for the readability, and gender diversity will be my independent variable. And then on the regression, the result is insignificant. So again, this one can be not used here. I'm trying to find a variable that might have some relationship and hold itself in the profitability. So let's say if we measure the relationship between gender diversity and firm value using Tobin Q. Tobin Q is a market to book value, which is a measurement, or Tobin Q ratio is a proxy or indicator of the firm value. Can the gender diversity improve the firm value? Let's try that. The relationship is significant at 90%. It is not under 0.5. Yes, it is not, it's insignificant, but because if it's less than 8%, is not that really significant. If we try instead of gender diversity, border size, again is insignificant. So if we replace the border size by border independency, the relationship is insignificant. So that's explain the importance of sensitivity analysis. You should not draw a conclusion only using your mean regression, because the mean regression will give you a significant result, but this is equal to 1-star, 2-star journal as a maximum contribution. If you want to knock the door of a 3-star or 4-star and create a significant impact in the research, you have to make sure that the result will remain hold whatever happened. So when you buy a new car, you drive the car and the car is driving good in the normal way. The next step is to take the car on the motorway. The next step to take the car in a rough road, in the mountain, in the desert. If the car keep performing well, that means this car is good. This is what we've done here. We run the mean regression, we try our car in the main road and it's working, but we still have to do additional further analysis, sensitivity analysis, to make sure that our result will remain in the same direction if we change the proxy of our result. So let's say someone change the gender diversity by border size. The result is insignificant. If someone choose to represent the gender diversity by audit committee independency, the result remain insignificant as well. That means our model is not a good model. So let's try to find a model that might actually work. So let's say if we measure regression and we choose WACC, weighted average cost of capital, as a result of the governance, border size, border independency, gender diversity together. You can see here the border independency improve. So if I take away the border size and I test the result between border independency and gender diversity and WACC, weighted average cost of capital, we can see the result here is significant and positive. Both of them under 0.05%, and both of them is a positive sign in the coefficient. So we look in the p-value and we look in the coefficient signal, which confirm that, suggests that our result is, there is a relationship between border independency and weighted average cost of capital at R square. Explanatory power of the model is 3%, and the number of observation is 898. This is the number of Fermi observation. So let's stick to this model and try to check the sensitivity analysis for it. So if I replace WACC, weighted average cost of capital, by another measurement, so for example, total debt to total equity, which can be used as an alternative proxy for the WACC, and I check the result became insignificant. That means we cannot claim that the governance improve or increase the WACC. Obviously, that makes sense theoretically. The governance should decrease the cost of capital, not the opposite way. If I try the governance pillar or governance score using the border independency and border size and gender diversity, we can see the relationship here is significant in all of them. So border size improve the governance, which makes sense. Border independency improve the governance. Gender diversity improve the governance. All of them has p-value less than 0.5%. All of them has a positive sign. Border size improve the governance. Each individual person added to the border size improve the governance by 1.52 units. and each percentage of board independency measured by the number of executive director in the board of director improve the governance by 0.67%. Gender diversity improve the governance by 31%. So let's stick to this model. So this is the OLS regression for it. If I want to test using different proxy. So instead of the governance power, for example, I will use social power or environmental power. Yes, can you see here? This is a good example of good sensitivity analysis. So what you will do in your discussion, you will come here, run one more time using, instead of social pillar, you choose the environmental pillar. It's still significant. And instead of the environmental pillar, you're going to use another proxy for the governance, for example, CSR, right? So the first three here, so this is the first one, significant, second one, significant, second one, social pillar significant, and environmental significant, right? All of them are 0.05. What should I do here? I will run the first one, and after that I will trig to using test.doc, enter. Do you remember this command from first week, second week, to take the result in a table? I will trig using any name you want, .doc. And then I will run the other module when I replace the governance pillar by social pillar. And I will do again, I will trig using test.doc, but I will add at the end append. Why append? If you remember, because I want to add this to the other table. I don't want to delete the original one. And then I will run the third model, which is environmental pillar. And I will say here, I will trig using test.doc, append again. And when I open your file here, which is called test, this will be your sensitivity analysis section in your manuscript, when you can describe that using different proxy for the governance pillar, the result remain significant. Does not have to remain at 99%, does not have to remain at 95%, as long as it's significant is fine. Sorry, I'm trying to open the file. Where is the file here? Test, yeah. Can you see here? So this will be your sensitivity analysis. Now, it's the first way of addressing the sensitivity analysis. You change the proxy for the governance. So first time you choose governance pillar, next time you choose social pillar, third time you choose environmental pillar, right? So you use different proxy for your dependent variable. And as you can see here, the stata suggests the result significant at 99%. We have 3-star. We have 3-star here, 99%. And we have 3-star here, 99%. And all of them, by the way, if you look at the board independency, 99%. Board independency, 99%. Here as well, 99%. And if you look in the gender diversity, 99%. Does not have to be 99% as long as it has at least 1 star. So it's significant. That means your sensitivity analysis does actually work. So you are replacing one of the dependent variable by different measure. If your dependent is profitability, you change the profitability. Instead of using ROA, use ROE. Instead of using ROE, you use Tobin Q. Instead of Tobin Q, you choose total revenue, etc., etc. Another way of doing that, and that self-explain itself, we don't have to do much about it. I will close the test here. I hope this is clear now. Don't save. We'll go back to stata, and we write here reg. And if we want to say governance pillar using total asset, firm size, asset, yeah, total asset. Does the total asset improve the governance? Yes. Why? Because here total asset is not actually total asset. If you're doing research in accounting and finance, total asset is a proxy for the firm size. So the bigger the firm, the bigger the governance, which makes sense. Again, we are not building a hypothesis here. I'm just doing as an example. So this regression model suggests that the bigger the firm, the higher the governance score, which makes sense. But how we measure the firm size here? Using total asset as a proxy for the firm size. So in your variable definition section, you will explain that you measure the firm size using total asset. In your paper, you will not discuss the total asset. You will talk about firm size, firm size. Firm size improve the governance. Why firm size improve the governance? Because with this theory, because of this literature, because of this finding, you talk about the firm size. But when you come to the regression section and a variable definition section, you will say that we use total asset as a proxy for the firm size. Is that clear? Okay. So in the first exercise, in the first example, we replace our dependent variable. The governance by environmental one time, by social one time, by governance one time. Now we want to replace our independent variable. So another way of running the sensitivity analysis is to find another measurement for your independent variable. So instead of using total asset, you might use total sales or total revenue, because total revenue in the literature has been used as a proxy for the firm size. You might use the number of employees. Here, the result remains significant. So what you should do here, you're going to run the first one, and I'm going to write Outlook. And here, we're going to use outreg using test replace. Why replace? Because I want to delete what I wrote before. It's a fresh table, right? And then I will use the total revenue instead of the total asset. And again, outreg, but instead of replace, I'm going to say append. I'm going to open the file that has total asset here. This will have my sensitivity analysis result. Sorry, it takes time to open here. Here. In the last time, we changed the topic. We changed the dependent variable. We changed the top. Now we are not changing the top. We're changing the independent variable. So one time measured by total asset and one time measured by total revenue. As you can see here, the relationship between total asset and total revenue, if we use the governance as a dependent variable, remains significant at 99%. So this is another way of running the sensitivity analysis. You can find another proxy for your dependent variable, another indicator. This is from your reading, from the literature, or you can find another indicator for your dependent variable, right? I hope this is clear. Another way of running a sensitivity analysis is to add more controls. For example, if I run the same regression here, at the end, I put here I.years. If you remember I.year from last week, we control for the year fixed effect. The result remains significant, right? So we control for the effect of any specific year on our data. Number of observation 966, 969. R square is 0.8. B value is significant at 99%. The probability of the model is 99%. B value is significant, and the result here is coefficient is positive. So there is a positive relationship between asset and governance. Why E is here? Do you know why E is here and how to fix it? If you remember week number 1, E is here because total asset number are million and the governance number is very small. So if you run sum, can you see here? The governance minimum 3 and maximum 96%, while the total asset minimum 24,000 and maximum 3 billion. And we explain in week number 1 how to fix this problem. We can replace the total asset by the logarithm of total asset. So I can say here, generate board size equal logarithm of total asset. And get the asset from here. Total asset, close the brackets. That will generate a new variable called board size. So when I run my regression, I will replace the total asset by board size, the new one. Sorry, firm size. I should have it firm size. Let me fix that. Rename B size should be firm size, not board size. And here will be firm size. When you run the regression now, the E is disappear. Do you see? If you run the first table we done earlier, here, this one, the result has E. So when you take it out, you don't really have to explain it. That's why we do some data transformation. So we generate a logarithm of total asset instead of total asset. So the number here can be explained. The result is significant, positive at 99%, and there is a positive relationship between firm size and governance. Let's do again for the total revenue. So I can say generate rev, any name you wish, rev equal logarithm total revenue, just to shortalize the number. And then I run regression here, and instead of using the board size, I'm going to use rev. The result remains significant. So what I done here, I have used one time the total asset as a proxy for the firm size, one time total revenue as a proxy for firm size, using additional control variable, and the result remains significant at 99%. Someone else might say, I want to control for the industry. That's fine. I.industry. The result remains significant at 99%. Someone will say, I'm going to put the industry and the year together. Enter. The result remains significant at 99%. All this is a sensitivity analysis. You check your model. If you add more variable, if you remove variable, if you change indicator, if you change a proxy, this is when we talk about 3-star and above level, right? So we add the control for the industry, fixed effect, year fixed effect. You might add another. So let's say if I take here the instead of revenue, board size or firm size, and I want here I.year and I.industry. The result is main significant at 99%. What if I control for other variable? For example, if someone control for liquidity using current ratio, because some people claim that the better the liquidity, the better the governance, for example. Someone control for gearing, the result remains significant at 99%. My variable of interest remains significant at 99% level B value. Doesn't matter what control variable if I add, right? So one more time to conclude what we have done, we use the first two methods from our PowerPoint here. The first one, we use different specification for the model. When we change our proxy, our indicators, we change the total asset to be total revenue or total number of employees. We change profitability from ROA to ROE. So we change the way of measuring things. Instead of measuring by kilogram, you measure by the gram, and the result remains the same. Instead of measuring by meter, you measure by feet, and the result remains the same. And we use a different method as well, using different control variable. So whatever you add control variable, or it change the control variable, let's say firm size or industry dummy, the result holds significant. Another way of doing that as well is to replace the dependent variable, the governance, from being continuous variable. So sum governance. If I sum the governance, my dependent, the governance here is continuous variable. What does it mean continuous variable? If I write tabulate, governance, look, it has a lot of variable. One time 98, one time 79, one time 80, one time 70, one time 30. It's a wide range of variables randomly distributed across my sample with minimum observation 3 and maximum 96. Do you understand that? So when we sum the governance, the minimum is 3 and the maximum is 96. Now we want to replace this variable to become a dummy variable. One of the sensitivity analysis is to replace this variable by a dummy variable. How to do that? You can say here, univar governance, which will give you the number of observation, the mean, the standard deviation. It's a little bit not straight because of the word, the name is very big. So let's say now if I want to make it straight for you, if I say rename, to make it short name, governance by GOF only. And I univar GOF. And I sum GOF. Right? Can you see here that this is a mean? The difference between univar and sum, univar give you more information. For example, the median. In the sum, you don't have the median here, right? It's better when you create a continuous variable is to use the median, not the mean. But because of our data is normally distributed, as we discussed last week, so it doesn't matter if you use the mean or use the median. Because the median here is 54.44 and the mean is 54.48, does not really make big difference. But if you have different median away from the mean, it's better to use the median, not the mean. Again, it depends on the literature. So what I want to do here, remember this number, 54.44. Go back to our regression analysis. When we run the governance power pillar, remember we replace the name by gov. This is our result, right? Let's remove the I dot here, I dot industry, just to make the table short for you. Can you see the final table here? We have a significant relationship between firm size and governance. We want to do a sensitivity analysis using the mean and the median. Remember, the median is 54.44. What we should do? We run the same command. We put at the end if gov bigger than or equal the median. Can you see that? Run the regression if gov is bigger than or equal the median. The result remains significant. Rerun the model if gov is less than the median. The result remains significant. Which one is more significant? Huh? Look at the coefficient. Which one has a stronger coefficient? Which one has a higher coefficient? The one when we have tested above the median. You remember? Above the median. So that's stand as an evidence to support our finding that the firm size is a major influencer or can be used as an independent variable for the gov. Because when we break our sample into two sections, above the median and under the median, the result was more pronounced when the data was over the median. One more time, one more time, one more time. What we have done here, we run univar to the gov to find out how much is the median. Gov is my governance, my dependent variable. And then I run the regression one time over the median and one time under the median. If the coefficient was higher, which is 2.77, here is 2.04, both of them are significant. That means our result, this is an evidence as a sensitivity analysis, the relationship is because of gov. Because when we divide the sample above and under, the result remains the same. This can work also if you divide the sample based on the firm size. What you should do here, you're going to say univar if size, you find the median of the firm size 20.75, and you run the regression here if size is above the median, the coefficient is 6.7, and if the firm size under the median of firm size, the coefficient is 8, it was 6, increase. So the lower the firm size, the higher the relationship. Again, explaining that in details, it depends on your context, what do you want to prove, what your hypothesis development, what your storytelling. We're just using an example. So one of the way in the sensitivity analysis, you divide the sample above the median and under the median. That can be used using another total different variable. So let's say now, can you see this regression? The relationship between governance and firm size using current ratio and gearing as a control variable. If, do you remember the industry? Industry type. Let's say if you know that the industry 1 and 2 and 3 are high risky industry, industry 4, 5, 6 are low risk industry. Let me explain that. The industry here in this data is ranked from 1 to 6 based on data stream classification. You might use different classification. In Bloomberg, you have 10 classification. Let's say I classify my industry into 6 main categories. And I order them. So category 1, 2, and 3 will be risky industry, and category 4, 5, 6 is low risk industry. Low risk industry. And I will run my regression saying that if industry is lower than or equal 3, and run the regression again if the industry is bigger than 3. So here I divided the sample based on another variable, totally different variable. When we run up less than 3, the coefficient is low. When you run above 3, the coefficient is high, 8.7%. And you can draw a conclusion here that high risk and the low risk industry will have a better relationship between firm size and governance. I don't want to put too much pressure on you to condense too much information at one time, but what we learned so far, using different proxy as the sensitivity analysis. So we change the profitability from ROA to ROE, from ROE to Tobin Q, using different control variable, adding different set of control variable to the regression, changing divide the sample over the median or under the median. This is another option. And you can change your dependent variable to be binary variable. Binary variable mean, if we get here the command, this is my regression, right? Can you see the relationship is significant all over? So I generate another variable and I call it gov_new, right? Equals 0, missing. Then replace gov_new equal 1 if, before we do this, we need to get the sum of or univar of gov. Univar of gov, we have the median 54.44. So we generate another variable called gov_new, right? And we replace this variable gov_new equal 0 if gov bigger than or equal the median. Do you understand what we're doing here? We are saying to Stata to generate another variable called gov_new and give it 0 if the gov is under the median. If the gov is under the median, give it 0. Right? And do it again, replace it by 1 if the gov is above the median. What happened here? If you sum gov_new, it will be a dummy variable, only 0 and 1. Minimum is 0, maximum is 1. What will happen here? We generate gov_new missing, replace it by 0 if the gov is under the median. So any company in our sample has government under the median will get 0, and any company in our sample have a gov above the median or equal the median will get 1. So we replaced our dependent variable from being continuous variable to be a binary dummy variable. Then we run the regression again. Instead of using gov, we're going to use gov_new. If the result remains significant, which is not the case here, we fail in this sensitivity analysis. If this remains significant, this is another type of sensitivity. That means our result suggests that even dividing the sample into high governance and low governance, which I did here, I divided the sample into high governance sample and low governance sample, and I run the regression, the result remain different. I can fix this problem. If I face this problem, I might try regress gov, the original one, firm size, current ratio, and gearing if gov new equal 1. And I do it again if the gov new equal 0. Can you see here? The result is significant at 99%, and here is significant at 99%. In the sample, considering the gov high, you remember when you replace gov new by 1, if the gov is above the median, you remember that if you go back here? So you notice what we have done here. We say gov new is equal to 0 if the gov below the median, and gov new equal 1 if the gov above or equal the median. So the gov new here is, if we want to name it in ourselves, it's a high and low government. High and low government. If gov new equal 1, that means high governance firm. If the gov equal to 0, that means low governance firm. And then we run our regression, the last two tables here. First one, we run the regression normally if gov new equal 1. So in the high governance firm, the result is 2.7, significant. In the low governance firm, which is in below the median, the coefficient is 2.4 only. And that's another sensitivity analysis, that in the higher governance firm, the relationship is more pronounced. The relationship is more exists. In the high governance firm, the relationship between firm size and the governance is more exist or more pronounced. By in the firm that high low governance below the median, the relationship between firm size and gov is lower. Although both of them are significant, but the coefficient is lower. So ladies and gentlemen, thank you very much. So we use here 4 different types. The first one, we use different proxies. We use different control variable. We change our dependent variable to be binary variable, dummy, and we divide our sample above the median, below the median, above the mean, and below the mean. We're going to leave the outlier detection technique because this is another set of tests for the time constraint. I'm here finished. Just before I open the floor for any question, the next class will be after 1 month and a half. So it will be May, inshallah, because of Ramadan. So we have 1 month that will stop presenting. And then with the next session will be at the start of May or mid of April. Will be announcement there in the ITAR Group website or by email. Thank you very much. And the floor is now yours for any question. I'll check in the chat. Has anyone typed anything in the chat?
Thank you, Doctor. Thank you so much. Okay, great. So let's see if we have any questions from the attendees. I can see that we have Ahmed Gouda,
Yes.
I think.
Yes, Ahmed.
Okay, Ahmed, you may talk. The mic is open. Or if you prefer, you can also.
Ahmed.
Hello.
Okay, Ahmed.
Yes. Hello.
Hello.
Yes.
Yes, please.
Hello, sir. Can you hear me?
Yes, I can hear you very well.
السلام عليكم.
عليكم السلام ورحمة الله وبركاته.
سؤال يا دكتور، حضرتك انت في الريجريشن بتعمل تحديد للسنة وللصناعة، الاي يير والاي اندستري. طب والاندستري دلوقتي هو في الاستاتا، احنا دلوقتي بنعمل لها تحويل للاسم، لان احنا لما ندخلها على الاستاتا بيكون اسم، بيكون استريك. فقبل وقت ما ادخلها على الاستاتا بعمل كاتيجوري زي ما حضرتك قلت.
Thank you very much for your question. شكرا لسؤالك. أحمد بيسأل. I will say the answer in Arabic and in English so the attendants in English can understand as well. So let's say it in English first. Ahmed or Dr. Ahmed say that we have the industry here. It is very important question for us as well to know. We have the industry here, and when you sum the industry, it's falling between 1 to 6. Although when you download the data from Bloomberg or DataStream or from any database, the industry is a name. It is not a number. So how do I transfer it to be 1 to 6? This was the question. So the answer for that, you can do it in Excel, but it's very easy in Stata. If you open the data editor from the top here, the data editor sign, and you go to the industry, which is not exist here because I've already had to change it, and you press right click, and we said that in the first week, if I remember, you go data and you say convert from string to numeric, that will automatically assign number for each industry. One more time. So if I go here to Eisen, because it's a string, I browse data, right click data. You can see here options say convert the variable from string to numeric, which will assign automatically a number instead of the name to each individual industry. So in Arabic, شكرا احمد على سؤالك. انت بتقول الاندستري حولناها ازاي؟ يا اما بتعملها على الاكسل من الخارج او من خلال الداتا اديتور. تفتح من هنا من فوق من هنا داتا اديتور وتروح على اسم الفاريبل، تك عليه تك يمين بيظهر لك داتا، بيظهر اوبشن اسمه حول الفاريبل ده من string to numeric، او ممكن تعملها على الاكسل بره قبل ما تدخل البيانات الاستاتيك. تمام؟ ده لو انت محتاج تحط الاندستري as a control for your module if you want to add it in your regression. I hope this answer your question, Ahmed.
Thank you, sir.
Thank you. Other questions? Muhammad, I think Muhammad Abdelal. Yes, go Muhammad.
Yes, Muhammad, you may speak. تفضل.
محمد.
ايوه دكتور، سامعني حضرتك يا دكتور؟
ايوه اتفضل، اهلا وسهلا.
طيب اهلا وسهلا دكتور. هل في انواع ثانيه يا دكتور من الروبيتنس زي البروبنسكي سكور ماتشنج او الانسترومنتال فاريبل؟ هل دي انواع مختلفه من الروبيتنس عن غير اللي حضرتك حكيت عنه ولا دي مش تبع الروبيتنس؟
شكرا جزيلا يا استاذ محمد لسؤالك. ده نقطه مهمه جدا. احنا ما اتكلمناش عن الروبستنس تشيك لسه بالتفصيل، اتكلمنا على sensitivity analysis. So Dr. Muhammad is asking whether this is everything about the robustness check or he's asking about the instrumental variable IV regression to SLS, GMM or other analysis that can be used to check our robustness. So I'll answer again in English and Arabic quickly. We just give a brief introduction about the sensitivity analysis in general. Later on, we have a special class for the robustness check when we have to talk in details about the IV regression, the instrumental variable, 2SLS, two-stage least square, and GMM, which is mainly there to tackle the endogeneity issue and other stuff. It's the strong class, so everyone has to have a little bit of ground understanding or foundation of understanding of regression first. But yes, this will be our next workshop, the robustness check using GMM, 2SLS, instrumental variables, and robustness score matching, BSM, and BCA as well, and all other regression that can be used in our robustness check, and how to combine variables as well. Let's say I have 10 variables for the governance, but I want them using the BCA to be only one variable. So there is Stata is like an ocean. We just take one dot from it. So slowly, we will progress. But yes, we'll come to this section called robustness check. So our class today is not a robustness check. It can be called more sensitivity analysis, which is one step before the robustness check. Does that answer your question, Muhammad?
Yes, جزاك الله خير يا دكتور، شكرا خالص.
Thank you very much. Someone put question in the chat. I'm going to read it. Naima, are the data in Stata should be balanced, especially when we want to run panel data? No, it does not have to be balanced. Again, it depends what you want to test and what your research question and what your hypothesis, but the data does not have to balance. You can have in 1 year 900 observation, and in second year 700 observation, one variable 1000 observation, another variable 6000 observation. It is not a must to balance your data before running your regression, unless you have a specific type or a specific question or a specific finding that needed for the data to be balanced in advance. Thank you. Any other question?
You answered the ones in chat, Dr. Mahmoud?
I answered the first one. I will read the second one now. I just noticed it now.
Okay.
The second one, Dr. Could you please share the PowerPoint as I joined late and I lost the track We'll watch it again and catch the next class, inshallah. Yes, inshallah, we'll share the document and all the files will be with Dr. Ahmed, the organizer. And the same time, the class is streamed online and you can see it on the YouTube at any time. You can go and replay it on YouTube at any time. Thank you.
Okay, great. I think, okay, I have 2 more questions. Khawla?
Okay. If my dependent variable is ROA, can I use as a binary like we did with Gov? Yes, you can use any variable. You can change it to be a dummy variable. You get the median or the of it or the mode and just divide the sample between above and under the median. That will work as a dummy variable for your regression. Thank you. I didn't catch the second question. Any other question?
It was just a thank you comment from the attendees.
Thank you. Thank you.
Okay, so I think no more questions as it seems, and no more hands or anything. Okay, so as Dr. Mahmoud said, they will announce the next part of their workshop, inshallah, and that would be probably after Ramadan, correct? Okay, so كل عام وانتم بخير جميعا ورمضان كريم ومبارك عليكم الشهر. وإن شاء الله we will meet soon إن شاء الله, and Dr. Ahmed إن شاء الله will be in touch and will make the official announcement. Thank you, Dr. Mahmoud. It's been a pleasure. Thank you so much.
Thank you. Thank you.
Thank
Have
you.
a nice day.
Good night,
Thank you.
everyone.